Hello and welcome back to my YouTube channel. In this video, I'll be going through the solution to exercise 1.24 from the C programming language textbook by Brian Kernighan and Dennis Ritchie. Now, exercise 1.24 says to write a program to check a C program for rudimentary syntax errors like unbalanced parentheses, brackets, and braces. Don't forget about quotes, both single and double, escape sequences, and comments. This program is hard if you do it in full generality. So let's see what that means first of all. So one solution, which is not done in full generality, and we'll see why, is if you just keep like two integer counters for the amount of open braces, brackets, and parentheses, and another counter for the number of close brackets, braces, and parentheses. And then what you can do is check at the end if you have an equal number of open brackets, open braces, and open parentheses as you do close brackets, close braces, and close parentheses, then there is no errors. Now you'll see why this is not considered full generality, because I could have something like this, and straight away you can see there's an error because this close parentheses is highlighted in red, but there is still only one open brace and one open parentheses and one close brace and one close parentheses. So in that case, if we do that solution, it will be considered okay, even if it's not. So it's not done in full generality this way. So I'm going to do it in full generality, but to do that, we need to introduce a new data structure. It's also introduced in chapter 4, but if you haven't reached there, that's fine. I'll explain it here. So basically what we're going to make is something called a stack. So a stack, I mean, as the name implies, is like a real life stack. Like if you have a stack of books, a stack of clothes, a stack of, I don't know, CDs, anything. And what we can do is push stuff onto the stack. That's like placing something onto the stack. And we can pop something off the stack. That's like taking something off it. So like we could push, or we could have a stack that just holds, I don't know, ages or numbers. So we could push the number 1. And then let's say we want to push the number 2 on the stack. Well, like in real life, when you want to put something onto a stack, you put something on the very top. So if we want to push the number 2 on the stack, we place it on the top. If we want to then push the number 10, we place it on the top. And also, like in real life, if you want to take something off the stack, you have to also take it from the top. So if we want to pop something from the stack, we will take the 10. If we want to pop from the stack, we will take the 2. If we want to pop again from the stack, we will take the 1. Okay, so how are we going to use this to help us check for syntax errors? Well, what we can do is, if we encounter an opening parentheses, bracket, or brace, then we're going to push it onto the stack. So my stack might look something like this. So it's always going to have opening parentheses, brackets, and braces. And then every time I encounter a closing parentheses, bracket, or brace, then I want to pop off the stack and check if they match. So let's say it's okay. So how can we check if it's okay? Let's say that, actually I'll make this a block comment. Sorry, bear with me. Okay, and I'll space it out so we can see it better. Okay, so let's say that is my standard input. So here we encounter a closing parentheses, bracket, or brace, namely a closing parentheses. Then we pop off the top item this opening brace, and we see, does it match? No, it doesn't. So there must be an error. If it did match, then we can just pop off what's here, take off this, and then we move on to the next one. And then we check, does what's on top of the stack match what I'm currently at? No, must be an error. And so you can get the idea. We check when we encounter a closing anything, we check if it matches what's on the top of the stack. Okay, now with that in mind, we can proceed, but we should also keep note of what the question tells us. It says we should not forget about quotes, single and double, escape sequences, and comments. And that's because we don't want to count any braces, brackets, or parentheses that occur in comments like this. We don't want to count that. Or in quotes. Like if it's like that, then also we don't want to count it. Single and double. Okay, with that in mind, let's proceed. So the first thing I'm going to do is I'm going to create a global variable called stack. So to implement the stack, there's many ways you can do it, but I'm just going to use an array. So I'm going to have a character array. It's going to be called stack, and its size, to get its size, I'm going to make a constant stack size, and I'm going to make it 100 characters for now. Stack size. Okay, and we should also have a stack position, and this is going to keep the index of where our array for our stack. And I'm going to start it off at 0, and it should be an integer. Now these are global, so I can use them in other functions, and because it's in the same file, like the book says, I don't have to use that extern keyword. Okay, so I'm going to make a function called pop. And the pop should return a character, which is whatever we get from the top of the stack, and it should take no argument, so void. All right, and let's write this function. So to pop something off the stack, we need to make sure of one thing. We need to make sure that the stack is not empty. Now the stack position is the position of the next free, like slot, if you will. So if the stack position is larger than 0, so if it's not at that very first slot in the array, if it's past that, then there must be something on the stack. And that way we can pop something off the stack. Now to pop it off, because the stack position is the next available slot, like it's a free position, we want to go back to the to the previous thing that was put onto the stack, and then we will return whatever's there. Okay, so if this is false, if stack position is not larger than 0, then stack position is 0, and that means we're at the very first position on our stack, which means it's empty. So otherwise, I will just return 0. We could have an error message, but it won't be necessary for this program. Okay, and I'm going to have another function called push. So push is going to not return anything, and it's going to take in a character C to push onto the stack. And so here I should make sure that the stack is not full before I push onto it. Otherwise, we're going to get some out of bounds indexing errors. So if the stack position is currently less than the stack size, then I can push onto the stack. So then I can say stack of stack position equals C, and then I'm going to increment stack position to be the next available spot. Otherwise, I'm going to print out an error message. Error, stack is full. Cannot complete syntax checking at this time. Okay. And that's our push and pop functions done. So let's get into the main program. So I'm going to have an integer C, and then I'm going to say while C, just the standard way of reading in user input. Okay, so like we said, we need to make sure that we're not at a comment, we're not at a brace, we're not at a comment, we're not in quotes, before we can start pushing and popping off the stack. So the first thing I'm going to check is if C equals a /. If it does equal a /, then we may be inside a comment. to check, we need to check the next character. And so I'm going to get the next character and store it in C again. I'm going to say if C equals another /, then I should skip inline comment. It means we must be at an inline comment, and I'm going to write this function now. And here is going to be void. Okay. Now we did write a similar function in the previous video for solution 1.23. It's going to be largely the same or mostly the same, but there will be one small difference. So we just want to skip over this comment. We don't want to print anything out. We just want to get past it. I'm going to say while C does not equal, we need to use sketcher. And we also need to make sure that it doesn't equal the new line character, because if it equals end of file or new line character, then it's the end of the comment. And what do we want to do? We want to do nothing. We just want to keep on getting whatever's in that comment and just skipping over it. And even at the end, we won't even put a new line character. So that will just skip past the entire comment. Okay. So that's a skip inline comment done. Function done. And then otherwise, if C is an asterisk, then I should skip the block comment. And so I'm going to have another function, skip block comment, and it's going to have void return and void arguments. Okay, and like we said in the previous video, we need to read 2 characters at a time because we want to see, we want to check for an asterisk and a /. And so we want to keep on reading while we're not at the end of the comment. If we're not at the end of the comment, that means that C does not equal asterisk or D does not equal a /. And like we also said in the previous video, we want to read 2 at a time, but we only want to shift over 1. So C should go to D and D can be the next character. And that is a skip block comment done. Okay, what if we're not at a /? What if we are at a single quote? Actually, let's say double quote. Now I also want to skip over it. So I'm going to make another function called skip quoted string. Okay, and you can probably see a lot of these functions are very similar to the previous exercise. So if you haven't watched that video, I recommend you do. So we're going to have an integer C for reading an input. C is going to be, we want to keep on reading while C does not equal the double quote. And then before, in the previous video, we would put char C, but we don't want to do that anymore. So now we're just going to check if C is an escape sequence. If it is, just skip over it by getting the next character. And just in case you haven't seen why we do that, it's because I can have something like this. And so you see, this is an escape sequence. I want to skip over it. I don't want to count this closing or this double quote as the closing double quote. Okay, so that's skip quoted string. And then what if we have a single quote? Then skip character constant. And this function is going to be very similar to the skip quoted string function. So I'm just going to copy and paste it. And make the one slight change that I need to make. Okay. And that will skip all the things that we need to skip. And now we can get to the actual stack handling. So otherwise, if we have an opening brace, or we have an opening bracket, or we have an opening parentheses, then we should push whatever's on the, we should push whatever we get onto the stack. And if we have a closing brace, or we have a closing bracket, or we have a closing parentheses, then we should do our checks. So what I'm going to do is I'm going to create a character D, or actually let me just call it top. And it's going to have whatever's on the top of the stack. I'm going to pop it off, and then I'm going to do some checks. So if the top is a brace and C does not equal a closing brace, then I'm going to print out an error message. Error expected closing brace. And I just want to get out of here now. I don't want to keep on checking. We have found an error. Let's just return. This is the first error we found. So let's just tell the user that. So we should return not 0, but let's say 1. Like maybe 1 indicates an error with braces, brackets, or parentheses. And so this return will just jump out of this main function and it will return the number 1 to main. Now there is a way we can check the number that's returned from main in our terminal. Maybe I'll show that later, but let's keep on going. Now, if the top element is a brace, or a bracket, sorry, and what we just read in is not a closing brace, then I'm going to print out another error message, and I'm going to say expected closing bracket. And likewise, I'm going to return 1. And then finally, I'm going to say if the top element is a opening parentheses and the current element I'm at is not a closing parentheses, then I'm just going to print out a similar error message. Okay. So that's that part done. What if, and actually I'll just mention one thing here, where's pop? Here with pop, if the stack is empty, then we just return 0. And so here when we pop it, none of these are true, and so we'll just keep on going. And so what we can do is, since this returns 0, if it's empty, we can say else if top equals 0, then we must also have an error. We can say printf there is no matching opening brace, bracket, or parentheses. And we could do some checks to check exactly what's missing, but that's basic coding. It's just going to waste us some time. Okay, now once I've done all of that, I'm not quite done, because this check here is good for checking if there's no opening brace, bracket, or parentheses. But what if there's no closed brace, bracket, or parentheses? then this never gets caught out. If there's nothing to close, I mean, this entire condition never even gets checked. So how do we know if we have missing closing brackets, braces, or parentheses? Well, every time we do get a closing bracket, brace, or parentheses, we pop. And so if there are no errors, then our stack should be empty. And if our stack is empty, then our stack position should equal 0. So if our stack position is 0, I'm going to print out a message saying no errors, well done. Otherwise, what should I do? And actually here I forgot we should return 1. Okay, otherwise what should I do? Well, I'm just gonna pop off whatever's at the top of the stack, and notice here I define top again because here top is only defined within this else part or this else scope. And then I'm going to say if top is an opening brace, then I'm going to print f error missing closing brace, else if top equals an opening bracket. I'm just gonna copy and paste that, missing closing bracket, and I should also return 1. Return 1, and I could have like a specific number for each error. That would probably be better, but I'm not gonna bother with that for now. And then otherwise, top must be it must be a parentheses, so I can just do an else parentheses and return 1, and that should be okay. Let's see if it compiles. Okay, no errors. And I'm going to open this test file, and as you can see, we don't have an opening parentheses. So to run it, I'm going to do this, and I'm going to redirect the input from test.c. And then here we go. It's at expected closing parentheses. Is that quite? No. Let's change the error message. Yes. The problem is this. Okay, let's give that one more go. So here we have this, and then it expected a closing brace here. And so, like you can see, the error messages are not perfect, but it catches out errors nonetheless. You can fiddle around with that and fix it up. Let's see just a few more possible errors just to make sure this works. What if we have no errors? Nice. And then what if we have that? Yep, missing closing brace. That's very good. What if we have that? Yep. And what if we have that? Yep. Okay. So the error messages aren't perfect. You can fix that up with a bit more if statements, but that is chapter 1 completed. So that will be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye bye.